Hello everyone, welcome back to a new episode of Advent of Code. We're going to do day 4 today, and for the first time, I don't have a long prelude to go into about the previous days. I just want to get started, so let's see what day 4 is all about. Day 4, secure container. Pardon me, I like just finished dinner, so I might be like stumbling over my voice a bit here. Secure container. You arrive at the Venus fuel depot only to discover it's protected by a password. The elves had written the password on a sticky note, but someone threw it out. However, they do remember a few key facts about the password. It is a 6-digit number. The value is within the range given in your puzzle input. 2 adjacent digits are the same. Going from left to right, the digits never decrease. They only ever increase or stay the same. Wow, this is like by far the easiest puzzle in Advent of Code this year, I think. Maybe day 1, part 1 was easier. I guess it was. Okay, so that's pretty simple. Okay, we'll do this kind of like a very straightforward way first, and then I have some ideas. I think it's kind of worth doing this one twice, to be honest. Oh, I'm in day 4, day 3. So what's the range in my input? There we go. Obviously, we could hard code this into the program, but I do kind of want to like write programs that read. I don't want to embed part of the input in the program. I want those to be separate, right? So that's why I've been doing this. So prepare is pretty simple. Case break on equal to dash. Oh, I guess my input then is actually a pair of ints. Within the range, increasing or decreasing? It doesn't say. Or inclusive or within the range. I assume inclusive. That's kind of the normal way to do it. Anyway, so here's our input. Break. What is the argument order for break? It takes the function first and then the list. So we're going to get back a pair from break, which is the things before the dash and then everything after and including it, right? So A and then B should be read A, read B. And HLint will warn me this is non-exhaustive quite reasonably. What is this warning? Is it redundant to bracket? It never occurred to me that this is a context where you wouldn't need the extra parents to disambiguate. Well, I like them though. So we can test this as like prepare of like 1 to 4, 5, whatever, and we get 1, 5. Now our input is going to have a new line at the end, right? So and I guess we'll get this from data char. And so now we still get the right thing we wanted here. Great. So I'm actually going to just bang part 1 out like pretty simply, as I said. Our output here is going to be. Actually, I don't even want an int, do I? I want a sequence of characters. Well, No, because we have to treat them both like strings and like numbers. So I guess we might as well make them numbers and then show them when we want to see. It is a 6-digit number. Is 0001 a 6-digit number? Well, okay, that was 5. But if 5 zeros followed by a 1, I think probably not. But anyway, the range we get is a 6-digit range, so that's fine. So part 1 is an input to an int. Low, high, I guess. And let's just do here. That seems pretty simple. Well, that's not going to work. We need to return an int. Length of do. Our n can come from the range low to high. And I mean, I guess honestly, let's use a. I never do this, but let's just use a list comprehension because guard is. Why is this not? Oh, I see. Right. So writing guard with do, you have to import it from control monad, and it's a little silly. So let's see. What are our conditions? We first must have that n is greater than or equal to low, and n is less than. Oh, we already have those, and we also know it's 6 digits as well by all these. So there's like almost no constraints, right? Let s equal show n. You can do that, right? That's legal? Yeah. I just use list comprehension so rarely, I'm never sure. So 2 adjacent digits are the same. Any, what is the type of any? It takes a predicate. That's not exactly what I want. Any, that's fine, I guess. Any uncurry of equal on zip. Well, any id, honestly. Any id on zip width equal s tail s. Any id, or is what I was thinking of, sort of. I don't know. So there's at least one pair of consecutive numbers that are the same. The fact that it's indenting to here tells me I must be using. Oh, hang on. This should be. I don't like the way Emacs is indenting this. Do I have to do this? No, I'm pretty sure you use commas for. Oh, maybe you're not. Maybe there is no let in a Haskell list comprehension let, but I thought there was. Yeah, yeah. What I'm writing is totally correct. Emacs is just indenting it weird, I think. Let s equal show n, and then we write some predicates that we think should be true. That should be true, and furthermore, oh, you know what? Actually, we can just zip them together twice. Pairs equals zip. No. Oh, there's some clever thing you're supposed to do with applicative style to zip a list with its tail. Ah, right. Zip tail Okay, and then we can say or, no, any uncurried pairs. And furthermore, all uncurry, they should increase or stay the same. So we want less than or equal to pairs. Not id, but equal. Okay. 1660. That's the right answer. Great. So maybe we'll get this committed and just try to make progress on part 2, and I'll show you the other stuff I was thinking of later. Okay, part 2. And Elf just remembered one more important detail. The 2 adjacent matching digits are not part of a larger group of matching digits. Still ignoring the range rule? Oh, I see. They're just saying that the puzzle ignore this, your input, when looking at the examples, which makes sense, of course. Uh-huh. Okay, so that's fine. Let's just write this real quick. I just want to actually do this one quickly since it's so easy. And then we can look at kind of how to write it in a prettier way. All. How do you? How do you see whether a list's items in Haskell are all different from each other? Or all the same, I guess. Oh, but I don't want either of those things. Well, I could, how to edit? I don't know. I should just zip the list with itself and the thing less than, I don't know, but do a zip with an offset of more and get a 3 tuple out, but it doesn't feel like the best thing. I don't see anything better though. All right, fine. So let's see. So I guess what I want is that all. No, not quite. I was thinking that I just want to add an additional rule, which is that all 3 tuples are distinct. And then, of course, you wouldn't run into any where you have a 2 tuple that's part of a 3 tuple. But if you had 1 1 3 5 5 5 or something, right? That would break my simplification. That's actually a little bit. I guess we just need to replace this. All right, we need 2 functions that operate on 3 things each, I guess. And it could be the beginning. If we pass it a 3 tuple, it could be the first 2 or the second 2 that satisfy it. We can't just assume it'll be the first 2 because when you get to the end of the list, there is no like third one. This is like way harder than I thought it was going to be. It's not hard, but like figuring out the right way to do it is. All the stuff I just wrote was like based on assumptions of size 2, right? And like something that cares about 2s and 3s at the same time is a little bit meh. And like 225555 is also legal, right? By these rules. Oh, look at that. They even gave that as an example. 1 is repeated, so it doesn't count, but 2 is only repeated twice, so it does count. We almost want like a zipper that looks at... I think it like looks at a pair and has the ability to look left or right from there. I don't know. We should just look at all 3 tuples and... Does that help? Not really. Okay. What we should have done to begin with was run length encoding, and then just look for, does the list contain a 2? Right? Yeah. So we'll remove this any uncurry equal and say, why is Emacs indenting like, it's just horrible here. I don't know what's, are you that mad about this comma? I guess, but Haskell people don't put the comma over here, do they? I mean, they do that for some things, but I don't think for list comprehension guards. Anyway, give me this comma back, and what I want to say is, okay, so in data list, probably in data list, no, there's like group by, right? Group by, or just group actually. Okay, yeah, so any equals 2 length on group of show n. It's in data list. Oh, sorry. You'll just get used to that on this channel. Group. So what I had just written was this. So group the digits in n, and if there is a length to group, then we are happy. We get 1135 following this rule. That's the right answer. Great. Nowhere near the leaderboard, I imagine, still, right? Personal stats. Yeah. In fact, doing not noticeably better than on any previous days. Certainly faster, but not like faster than the average. Actually, day one was easier than I remember it being. Oh, that's because I had to record it twice. Okay, fair enough. I forgot about that briefly. So, all right, let's commit this. And the thing that I kind of wanted to show off is like not going to make this more readable. I don't know, it's another one of those things, huh? I was just thinking of the fact that like maybe we'll just talk about this a bit in the REPL. Not bool. Monoid. So all is a new type wrapper around booleans. In the same way we have sum and product for ints, we have any and all for bools. This is because there's two possible monoid instances for bool. You could like or and basically, right? And so you shouldn't have one of them be privileged. They should both be new type wrappers over bool, where bool is not a monoid. And there's kind of a cool thing, which is that functions have a monoid instance if the thing that they are producing is itself a monoid. And I don't know, this is like, is this really all that amazing? I don't think I'm going to write the new solution using this, but the thing that I had briefly in mind was to frame our list of constraints as data itself, right? Rather than being what it is now as just kind of like, you know, here's a constraint. And it's not really stated as a value or anything. It's just like this function that's applied to some value in the middle of a list comprehension some number of times, right? It would be kind of nice, the domain modeling would be a bit better if we had this lifted somewhere, a list of all the constraints, right? And then we just ran all the constraints over the list, the input list of possible candidate passwords. I left some extra white space in there accidentally. And so then we would have like constraints as a list of int, I guess, but really like just string is fine because we're treating it as a list of characters. To all. Yeah, it's not defined, but constraints equals like and then we can just define our functions as a list of Boolean predicates. Actually, I know Haskell just put the comma here when they're writing lists. Although, what do you do with the first? Do you do it like this? Why? Oh. Oh, it's not a list of yeah, so I guess we would then be zipping it together I don't know. I'm doing things all wrong. I guess we have like or. I don't know. I mean, I could write a new lambda here that like lambda x is to. Oh, hang on. Was the problem that I needed parentheses here? I don't know what the relative. Yes. So here we have like a list of the constraints for our problem, right? And we could bring this one in as well. Although, actually, like, let's not. So this is like the constraints for part 1, right? And then we can say like just length of filter mconcat constraints on low to high. Okay, I guess we need to... There. So we could like make this a little bit prettier. For example, let's now take, let's extract out most of the work from part 1. Search is a function from input to int. Which is this. Part 1 is just search constraints, right? Oh, we need a new argument. Let's remove the mconcat here, and we'll just take a single constraint. And it doesn't take an input, it just takes a string to bool. String to any. All right, the type's getting a little bit silly. String to all, I mean. So there's part 1, right? And we haven't really like made things any simpler. We've just moved some of the complexity around. But now part 2 is just search of... Well, we don't even really need to represent it in a list. We could mconcat and save that as just a single string to all. But it's kind of nice to do it in lists first, I think. Search to mconcat of... where are my parentheses? Like this cons to constraints. Oh, I need to like get all. I need like all here somewhere. There. So like, there are definitely better ways you could structure this, I guess. The fact that like we're working with the all monoid instance kind of leaks all over the program, and that kind of stinks. But like part 1 and part 2, I was able to reuse the constraints in part 1, right? Except like it's kind of silly because this constraint ends up not being used in part 2. So I don't think this resulted in the program being any better. And so I'm sort of glad I didn't do things that way. I decided to just sort of do it the simple way. But I thought it would be interesting to at least show what I was thinking of with like this idea of, you know, function from A to bool being a monoidal thing that you can concat together. I don't know, monoids on the brain, I guess, given like my kind of perhaps overzealous approach to yesterday as well. So I don't think I will commit this. I think I'll like just throw this out. How do I don't know. Can I just like, can I do this? Yes? Oh, I have unsaved. Whatever. We'll just do it as I don't know how like the key bindings for whatever. I don't know what the key bindings in Emacs are like for complicated version control operations. All I really know is how to do like blame and stuff. But overall, a really simple, short day 4. Like, kind of nice to take a break. Did part 2 really take me 22 minutes? 32 minutes? Look at this. How long has this video been going? Only we've only going for 32 minutes total. How did my time end up being 56 minutes for... I don't get it. Right, like 56 minutes? The puzzle hasn't even been out for 56 minutes. It's 9:37. Maybe I just don't understand how the leader, the like... I don't see any other explanation for what these times are, and they look about right for previous days, I think. Maybe? Anyway, it doesn't matter. I'm just like kind of puzzled about what's going on there. I guess something that I should do is explain some of the stuff that I wrote here when I was just like kind of trying to be relatively quick and I didn't say much about what it did. Oh, I'm so... I don't know why. I was reading this last row as day 4 somehow. Yeah. And that explains why day 1 like was faster than I remembered it being. It's because that wasn't day 1, that was day 4. Okay. So even despite struggling for as long as I did to figure out how to do with the 3 tuple in part 2, still did substantially, like 2,000 people finished part 1 before me, but only 1,500 finished part 2. So I was like faster than average for part 2. So people like had a lot more trouble than I did on this, which is a bit of a surprise to me. Anyway, so the stuff that I like wrote but didn't explain. We have like a list comprehension. This is pretty simple. This kind of like bears some explaining, and I've talked a little bit before about how like function is itself a monad, and that you can use monadic and applicative operators to write interesting functions. So let's look briefly at how that works. How do we even do that? How do I explain the point? I mean, I could just write out the type equations for you and substitute things. But basically, the function functor slash applicative slash monad listed here, like, I mean, they're all listed here, right? Are this notation is like, take the function type and apply a single type to it. That yields a type with one argument, right? So like, functions taking int as argument is a functor or a monad. Sorry about that. Almost spilled a glass of water all over my keyboard. Functions taking string as argument, like any type you choose is a monad, but like that type doesn't vary. Whereas the type that you return does vary under the monad or applicative or whatever. And so fmap is just function composition, which is kind of cool. Like, you know, head dot. Let's not write those two words together, huh? Well, I can't even think of two functions. I'm just like, I'm mad. Tail and show, right? That's a function. You can compose those together, and like 5, you get back an empty string. You know, 500, you get 3 zeros. But you can also write like tail fmap into show, and that's the same thing. I wish GHCI wouldn't tell me about type defaults. I love for HLint and flycheck to tell me about it, but not GHCI. I don't know how to make that change. And so, like, I like to think of the function monad as having implicit access to a single argument being like the thing that it does. And so tail and show, at being functions of only one argument, have implicit access to their only argument, and therefore, like, f-mapping something into show kind of like makes sense. What's kind of more exciting is if we say like zip tail these are both, you know, and also let me show you the type of this. So for some applicative, it takes a function, a function from A to B inside of an applicative, and an A inside that same applicative, and gives you back a B in the applicative. So here, the applicative is kind of like pretend the first argument doesn't exist, right? And what we get is that like zip tail of x is equal to zip x tail x, right? The zip implicitly gets its first argument because it's like being treated as this applicative thing, and tail implicitly gets its first argument, and then we tell them both that composed function, oh, by the way, your first argument was x, and then they both sort of resolve themselves. That's why, you know, as we saw a few videos ago, so like it says true, right? This statement that I wrote is true. That's why we saw in like a previous episode that join cons fuel is equal to cons fuel fuel, because join cons is equal to lambda x cons x, and then apply that to x again, right? You implicitly get the first argument given to you twice. So, I don't know. This was like a not very good crash course on the function monad, but I just like wanted to sort of make maybe this kind of little trick a little bit more apparent. Any and all, I think, are relatively clear. They take a predicate and a list-like thing and tell you whether that predicate was true for any or respectively all elements in that list-like thing. Uncurry, I don't think we've seen yet. Uncurry takes a function of 2 arguments and returns a function that wants a tuple. So equal wants 2 arguments, but any wants a function that takes an element of pairs, and pairs is a list of tuples. So if we uncurry equals, we get back a list that wants a function that wants pairs. We give that to any, and it runs it over the list of pairs. I think the group trick is relatively straightforward, right? Group, I don't know, I guess I might as well show group of 1, 1, well, let's do it. I don't want to type commas. A, B, D, A, C, 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 Y. All right, we get back the list split into adjacent equivalence partitions. So taking this and equals 2 composed with length is a function that looks at a list and says, is your length 2? And if any of the lists have length 2, then they are part of a pair and are not part of a triple. So that was sort of the idea. It took me a while to get there because I was so focused on zipping together either like a 2-tuple or a 3-tuple. The idea of grouping like pairs did not occur to me for a while. Okay, well, looks like we are done with today's episode. I hope you enjoyed. Thanks for watching, and I'll see you next time.